Hello, beyond tellerrand. So they say that you see your whole life flashing before your eyes the moment you think you're going to die. But that's not the way it happened with me. What I remember was grass, a lot of grass. As I was running for my 6-year-old life, I remember the feeling of grass brushing along my shins as we ran through the field. I remember the sound of the grass as our pursuer was coming behind us. I also remember the sight of the machete that landed literally a few feet away from my ankles. Let me tell you what happened. True story. There was this man who was in this town where I grew up, and the man's name was Wakila. This is a true story. Wakila was a notorious local madman. I'm not talking John Hamm, Madison Avenue, the guy you see on TV madman. I'm talking crazy, I'm gonna kill you madman. And so one day, my friend and I were walking home from preschool, and we're walking down a trail along the fields in Tanzania. And as we walk, we noticed that there's a gentleman walking on the road. We're on the trail, he's on the main road, a little distance behind us. And we noticed that he's carrying a panga, a machete. No problem. No big deal there. A guy walking behind you carrying a machete in Tanzania, nothing to go home about, except we noticed that this man was Wakila, crazy as all get out, and armed. And my genius friend decided that this was the perfect moment to provoke Wakila. And so what he does is he turns around and yells, "Wakila, kicha," which means, "Wakila, you nutcase." And so what Wakila does is he sets his attention on us, and this look comes on his face as though, this seems like a particularly beautiful day to kill me some 6-year-old brats. No kidding, the guy starts charging at us with his machete, and we're like 6-year-old kids. And so of course what we do is we dash into the fields, and we run as fast as our 6-year-old legs could carry our dwindling lifespans. Now most of us here, I would guess, have never been chased by a machete-wielding madman. But I would venture to guess that every single one of us here knows the experience called fight or flight. Fight or flight. It's that moment of amazing mental efficiency where the human operating system, on the onslaught of all these signals and streams and messages coming in, distills innumerable variables down to a surprisingly clear, simple, and single binary decision. Put them up or go home. Fight or flight. And in that moment, we have this mechanism in us, before even it gets to our consciousness, which determines what information in our surrounding and in our context is useful to bring into our awareness. And so we have like an interface, an attention firewall, a load balancer inside our head, which tells us the smells, are they useful? Do these go to your attention span? The sound of the grass, is that useful? Does that go into your attention span? Memories of your homework, is that useful? Does that go into attention span? And the purpose of deciding and preventing things from going into your attention span is to allow your attention span to be able to be used for the maximum possibility of success in your given situation. In my episode with Wakila, my attention span was filled with grass because that was our escape route. But the point is, attention is a scarce commodity in our body, in our minds, and we have this inbuilt mechanism which helps us control that we don't overload the capacity. And so what you experience is tunnel vision. And what happens in tunnel vision is a little bit funny. Your eyes dilate, which actually lets in more signals, not less signals. And it should be more confusing, right? You're getting all this light coming in, all this messages and light information. But at the same time, your body only lets you see in this very small attention space. And so all that information that was coming in is being processed subconsciously to make sure that there's no other dangers that need to be brought into the attention space. But the information coming into your attention space is very limited. Why? So that you can maximize the possibility of success in that moment using the limited capacity you have in your attention. Aggressive optimization on the basis of attention. There is something that designers and artists really get. They know this, and that is attention is a precious commodity, and it's zero sum. Attention paid in one place is attention poverty in another. And so when we're looking here at this image in the screen, few of us are paying attention to the color of the curtains or the lines on the floor. What do we see on the screen? A ballerina dancing. But what you're actually perceiving is much more information than that. But that's not useful. What is useful and what is interesting is a ballerina dancing. We're very impressed with our body's ability to sense things and gather information about our surroundings. But we often take for granted how crucial it is that for all this information that we're receiving and processing and we have senses to perceive, that for any given time, most of that information is ignored. It's actually a phenomenal ability. It's a thinking process that happens beyond your thinking, ignoring information that's not useful. Now, fight or flight is an instance of an extreme situation which brings us to light in a useful way. But you're doing this all the time. When you go to the movies, you ignore the things at the border of the screen. When you go to watch a play or a ballet, you ignore the scaffolding around the stage and you focus on the performance. When you listen to music, you ignore the drowning noises of the traffic and the chatter at the Starbucks, and you listen to the music, to the strings and the harmony. Even as I'm speaking right now, you're not paying attention to the size of the space or to the fact that you can, if you listen, hear your heart beating and the sound of your breathing. No, those things are being filtered away so that your limited, precious attention span can be maximized so that you can engage as I speak with you. And so all information systems have this property, that they're limited by their bandwidth. And our bodies and our minds is an information system. And the digital ecosystem and environment we live in is also an information system. And it has a bandwidth limit as well. Technology only has its meaning and context in relationship to human beings. And as soon as the human information system comes into contact with the digital information systems, the limiting bandwidth is not what our processing chips can do, or the lag between the signal poles or to the server. What is limiting is your attention span. It is a finite commodity. You only have 24 hours in your day, and you have a pretty constant amount of processing capacity in your head. And so this is very important. The big idea that I want to discuss with you today is based on this notion that attention span is a limited capacity, and it doesn't scale. And so what I want to talk about is how can we, in this world where we are under a burgeoning volume of information and signals and messages and tweets and retweets and chirping and beeping and buzzing and now tapping on your wrist, how do we maximize our attention? How do we cope with a world which is going to be exploding with more devices, with our connected homes, with our connected shoes, connected cars? And when the rise of the rest happens, when the rest of the world gets on social media, how are we going to possibly keep our sanity under this tidal wave of information? That's what I want to discuss today. And the importance, I think, in this is that when we're developing or designing things, we're often focusing on solving the small problems in the context of our projects or the tools or products that we're building. But by the time you come to launch or release, your work is always going to go into a bigger system, into bigger platforms, and into interfaces that are going to propel it further. And for me, it always is very helpful and stirring and inspiring when I look as far above as I can on basically the entire picture. And that often informs my notion of what I'm doing, our go-to-market strategy, what are the things that are the priority that I should be working on. And so for me, this is as far high as I can go and as far as I can see, which makes sense in the direction we're going in information systems, with the web, with the internet, with mobile technology, etc. And what I see and I notice is that if we cannot manage our attentions properly, there is a serious risk about falling off a usability cliff. And I want to explain it this way. This is Stephen Wiltshire. Stephen Wiltshire, mute in his youth, At the age of 3, he was diagnosed as severely autistic. But at the age of 32, he was awarded membership into the Order of the British Empire. He was a knight. They knighted him because he was brilliant. Stephen Wiltshire can do something that none of us can. He can do this. What's mind-bending about Stephen's work is that he draws photorealistic cityscapes from a single glance and then from his memory. Not postcards, not photos. He just has a cursory glance at the landscape, and he goes into his studio and he makes these massive pictures. It's absolutely beautiful, and it's amazing. Now, what may surprise you is the reason why Stephen can do what he can and you and I can't. And it's not because he can see better than you. It's not that he's able to perceive things better than you. Those who've studied the autistic and the savants, they say that we perceive just as much as Stephen Wiltshire, and they would. The difference is not in him having an ability that we don't have, but him lacking an ability that we do have. A thinking interface that helps him control the amount of information that goes into his attention and that remains in his subconscious. So you're seeing a lot of things right now, but most of those remain in your subconscious and very little goes into your attention. With Stephen Wiltshire, all of that goes into his attention, or most of it goes into his attention. And so he remembers it all, and he sees it all. And when he's drawing, he says, I'm just seeing the picture. But it comes at a cost. If attention is a scarce commodity, if what you pay attention to is literally an economic transaction with returns and risks, that means that the amount of attention that he's paying in receiving all these signals about what his eyes see is diminishing the capacity he can spend on other things, simple things like social interactions and speech and things like that. And so it's really important. And it's not a malfunctioning of our bodies that we forget a lot of things and we ignore a lot of things. It's actually a capacity. It's kind of like a load balancing and a firewall. We literally live under a cloud that's raining signals and messages and data at us. And I think if we're going to understand how to build interfaces that can help us cope, interfaces that are usable, that don't let us end up falling off a usability cliff, but enable us to actually maximize our experiences with digital devices, then we need to understand a little bit of how we actually got here. And so I want to talk in relation to building systems and platforms that think for us and help in our conserving our attention. I want us to think about the advent of notifications and its context in Moore's law. Moore's law is an observation, and a fairly simple one. Gordon Moore observed, roughly speaking, that the amount of computing power in a given space of transistors tends to double every 2 years. And so anyone who has a basic understanding of math knows that the power of Moore's law is exponential growth. What he's saying is not that computers are going to get faster. What he's saying is that computers are going to get a lot faster, a lot faster. That's the power of Moore's law. And it's easy to understand the math behind that. But what is utterly mind-bending and hard to grasp are the consequences. The implication of Moore's laws are really hard to forecast. Moore's law is fundamentally not about computers being able to do more things, just being faster. The implication of Moore's law is Uber. It's the changing of social protocols because of computational powers. So because everyone has a computer in their pocket, which can locate them physically, and it's constantly on, and can communicate with servers on the cloud, because you have server farms where you can do computations on large numbers of people really quickly, it enables you to build a service which kind of disrupts taxi services and sharing cars. And so you have the Uberification of things, implication of Moore's law, the Netflixing of television. the Amazoning of retail, the Spotifying of radio. These are all implications of Moore's law. There's a great example of what it means when a social protocol changes on the basis of computing and technology. Consider, for example, the telephone number. The telephone number has a different function today than it did 20 years ago. 20 years ago, when you gave someone your telephone number, essentially it was an address. It was an address and a vague promise that if you would call me either at my work, one location, at a payphone, another location, or at my home, and if you called me at a particular certain hour, we can probably arrange a synchronization of our attention, and we can have a teleconference. So if you called me at 6 or 7 p.m. in the evening, and you called me at work, you won't find me. But if you called me in the location at home, that telephone number, we could have a conversation. And if you'd call me around 12 o'clock in the day, you need to call me on the telephone that's at work so we can have a conversation there. That was the kind of the social protocol. I give you my number, I give you access to these locations where we can then synchronize our attention and we can have dialogue. Enter the mobile phone and all that changes. It takes away the need of location. And so it's not about the protocol of allowing people to synchronize their location and attention. Essentially, when you give someone a telephone number, you're giving them direct access to your attention. It's not a vague promise of synchronizing how you guys are going to teleconference. It's a direct access to your attention. And you're giving them the implicit permission to interrupt you any place and at any time. That's the implication of Moore's law applied to telephone numbers. And so the implication of Moore's laws changes protocols, but it also changes metaphors. Steve Jobs had this phrase and this notion, and he said that computers are like the bicycle of the mind. That is, we apply a little bit of force, and the computers apply even more force, and therefore it can take us further. But under the weight and implication of Moore's law, that metaphor kind of starts to fall apart. Consider this. The blue line is our attention capacity. In the 50 years since Moore articulated his hypothesis, our attention span has remained the same, averagely speaking. It doesn't scale. It doesn't grow. It's a finite resource. At the same time, computational power is increasing in orders of magnitude exponentially. And so there comes a point in time where the computers are processing information faster than we can actually receive them. And they're sending signals because they're optimized to communicate and to send signals, and they're sending them faster than we can process them. And so it's not we who are driving the conversation anymore. It's not we who are peddling. It's the computers that are coming to us with questions and suggestions. It used to be the fact that we would go into Google and search. That's no longer the mode of operation. The information is pushed to us in streams, and it just comes to us through notifications. And we've got streams and streams and streams of information and serendipity. And all these things are run by algorithms, deciding what you may like to buy, who you may like to talk with, where you want to go eat, where you want to go travel, the weather. All these things are just algorithms. And these machines and these devices, these servers, they're just haunted with artifacts of our digital life, and they're just computing on it at a faster rate than we can, and they've got all this information to send to us. But we are a bottleneck, because as they're scaling, we remain constant. Now, in the advent of computing, the way you used to do it is you used to do time sharing. You would write your program on these cards, and you would take it into like a room, and you'd wait until the other guy got out, and he got out, and then you went in and you put your card in the machine. And then you could go do your laundry, go pick up the kids, go have a coffee, go do whatever you want to do, and then you would come back, and then the machine would be ready. And it would spit out to you the 7th digit of pi, a day's worth of work. And then you'd congratulate yourself, take your program out, pop the collar of your white coat, and go do something else until tomorrow, the 8th digit of pi. Moore's law, the implication that's completely changed. Computers are now time-sharing on us. They've got much more computational power, and so they want to tell us a lot of things. They want us to tell us what to buy because that's what they're optimized for. They want us to tell us what to look at because they're optimized to advertise. But we can't handle it all. And so they send us a message, and they're kind of waiting, are we going to retweet that? In the meantime, they're crunching numbers on the social graph and on weather, and they send us a weather report, and they wonder whether we're going to follow the link and buy a new umbrella. They're waiting for us to interact, but now it's them waiting on us. It's not us waiting on them. The implication of Moore's law changes protocols, it changes the metaphors we think about in computing. And because these devices are with us all the time, and because their power increases exponentially, and because that they're on all the time, the stream of consciousness from the computer to us is constant. And as human beings, we communicate with one another through messages. You could say that's the token of our communication. Well, computers communicate with us through notifications. That's like the token of their communication, human to computer. A study says that, on average, we receive 60 notifications a day, 60. And you haven't got your smart connected shoes and your smart connected car yet. And I don't know how many of you have a Nest in your home to talk to you. We're facing a usability cliff with regards to our attention. So what do you do when you realize that you've built Ultron? The biggest spam bot that's ever been created is not a person, it's not even a company, it's just the internet, this system, and it's got no kill switch, right? And it wants to communicate with you, and it's going to throw you off a usability cliff. What do? You cannot go back. That's not an option. Technology doesn't work that way. Moore's law doesn't work that way. You cannot just turn off all your notifications. I tried that. You can't commit Facebook suicide. Well, you can, but sooner or later you're going to pop up on some other social network. Sooner or later. A friend of mine was telling me how insecure and stupid credit card was, and I asked him, do you use a credit card? He said, yeah, of course. Going back is not really an option. You can forgive the creation of atomic weapons, but we can never forget how to split an atom. What's past is past. What do our bodies do? When we're in the threat of being flooded with information more than we can process, what do our bodies do? They think before we think. They process the information for us, and they harness the computational power that's innate in our cognitive system to help us reduce the load. Reduce the load. I'm just going to get a glass of water. All right. So they help us reduce the load by doing actually more work and thinking actually harder. So I did this. It was a pseudo experiment. It was a few days ago. I was sitting with a young lady for coffee, and I knew I was going to talk about this, and it's been my experience that switching my notifications just off was rather crude, and it didn't really work. Because what would happen is when I would come back onto my phone, it would just be like a tidal wave of information coming at me. But anyway, what I did when we were sitting over coffee is I did an experiment. I put my phone on the table, and I put it on silent, and I basically sat there with my arms crossed, and I said, let the world burn. I'm not picking up that phone. And so I had this conversation. And then a few minutes later, half an hour, I think, later, I pick up my phone and I look, and this is what I found there. I think you can see that, right? And this is not all the messages that came on. There were even more stacked up here, but these were all the notifications I had. And this, for me, is noise. It's not information. When the volume of signals coming through a channel exceeds the capacity of that channel, what you end up with is noise. And what's missing here is hierarchy. I don't know what's more important. And either I can be sitting across the table and acting autistic, looking at my phone and flicking at it and taking care of my notifications and information coming through my phone, or I can sit there and basically fall off a usability cliff because the next time I use my phone, I don't know if my house is burning down, I don't know if there's an emergency at home, I don't know if I got an important message coming at work, I don't know anything. Not until I dig myself out of that mess. But then if you look a little closer here, you can see what possibilities exist for how the system can be improved. One of the messages you see down here is a notification I got from Yahoo telling me that they're doing some maintenance scheduling. Okay, so in my ideal world, I'm sitting across the table with this friend, and we both have smartphones. We have Bluetooth, so theoretically, these phones could communicate with one another and know we're sitting next to each other on the table. The phones have also GPS, and they also have Wi-Fi, so theoretically, they can know that we're sitting in a cafe. And we are also friends on Facebook, so theoretically, a system can know we're two friends sitting in a cafe next to each other. Do I want to know about Yahoo's maintenance schedule? No, I don't. That information doesn't need to come to my consciousness at this moment. So get rid of that. Fortor is telling me about Mother's Day. Get rid of that. I'm trying to have a coffee and a conversation. I don't need to know about that. Typeform is telling me about their new feature that came out. Get rid of that. What do you do with these notifications? You queue them. And maybe you group them. And you snooze them. And when my phone realizes that I've come back home and it's 7 o'clock at night and I'm alone, maybe that's when you bring these trivial informations to my awareness. And that way, you've saved me from falling off a usability cliff when I was in the cafe. But in order to do that, you need to know what's important to me and what's not important to me. And then I had a friend at that same time send me a Bible verse to encourage me, and then he sent me a text message to tell me that he sent me that email. He's thorough. Now, situational awareness. I'm sitting here at the cafe with this lovely friend. I'm not going to suddenly go all millennial on her and pull out my smartphone and start quoting her scripture while I'm sitting in a cafe. I should be talking with her, right? And so this information can be queued up and wait for my quiet time in the evening when I'm more relaxed and I'm on my own and I can read through these things. That could have also gone. Most of these notifications actually shouldn't have been there. They shouldn't even have come up. Maybe if my house was burning and it had some sensors, there should have been an alert. But aside from that, I should have been able to keep my notifications on and still not have fallen into this usability cliff. None of these things is actually, I think, so far out there. The technology actually exists to do this. It's just that we need the systems and the protocols to pull it off. So what would it take? What would it take to have my phone think for me? What would it take to build an interface that helps me think, rather than an interface that's drowning me in information? Identity. The phone needs to know me much better than it actually does. Really does. My fight and flight reflex kicked in when Wakala was coming at me, and it kicked in efficiently because internally, whatever that logical system is in my body, it knows my secrets. It knows my fears, and it knows my hopes. It knows that I want to go home and see mom. I'm a 6-year-old. I don't want to be hacked to death. But when information is coming into our phones, all it has is just parameters, contact parameters. And they're coming from disparate silos. And they're all just being displayed on our phones kind of agnostically and not based on our identity. So I just want to read this because this for me was so spot on what Rebecca Cox said. The first company to fully execute on embedding your identity into your phone, making it truly a first-class experience, wins the next decade. Rebecca Cox said this 2011, I recall. That was brilliant. It's brilliant because she's talking about what she thinks is the next Google. And it's brilliant because of how she defines identity. This will surprise you. This is how she defines what identity is not. This is not identity. This is what your phone has, but this is not identity. Your password, your root access, your calendar, your emails, your location, your user account is not your identity. These are not your identity. What is? Identity is not a what, it's a how. A how of what? It's how you manage your attention. This is your digital identity. What does that mean? Well, theoretically, we can have the exact same Twitter followers. We could even, if it was possible, have almost exact same handle, and we'd still be completely different people. How? Well, it's because of our relationship with all those people with whom we're in contact with on Twitter. It's how we relate with one another. It's where our attention goes, in what times, and in what contexts. So those who get my attention during my work time are my work colleagues, regardless of whether they work for my company, Gentix, or they work for the Erste Bank. Those who get my attention when we're at home in my dinner table are very likely my family or close friends, which Vin Diesel would call family anyway. So let's call them family. So your attention is not just a bunch of data, and it's not a technical achievement, as he says. Your identity is how you manage your attention. And so if someone, or if a system would emerge which allowed us to program or encode the mechanism that we would like to manage our attention, that's a serious killer app. And that's how you stave off the tidal wave apocalypse of signals and notifications. It's really clever. It has profound implications. And so what's needed in order for us to embed identity into our devices? The best place to embed identity into our devices is the operating system. Why is that? Well, it's because that the applications on their own only can see a subset of our functionality and who we are. So there's a reason why it's not my eye that makes a decision what my hand does. And it's not like my toes which make my decision of what my eye does. We have a central operating system somewhere which collates all this information, and then based on my identity, based on the things that I want to do, based on the things that I fear, it then decides where and what information comes into my attention span. And so the best place to embed identity is actually on the operating system. And if you look behind, just a few slides behind here, as you can see, almost every single one of these apps is a different one. And they don't share information very clearly. They share some parameters, but they don't share my identity. What if the operating system could gauge my identity and collect these messages and even rewrite some of these notifications and decides to show me, discard, or snooze things automatically based on where my attention should be placed based on who I am? This gives these players a really big advantage because they have operating systems. But you're not discounted if you've got a platform. So Facebook, for example, they know that they're not an operating system, but they've got massive amounts of user data. What they tried to do was the Facebook Home, which was essentially kind of like a takeover of your operating system, but that didn't work. But what is proving very successful is taking it over using a platform, their messaging platform. And they were very serious about taking away their messaging app and making it a single standalone application so that now they can use their messaging app as essentially a separate runtime on top of your phone system. And what this allows them to do is eventually they're now controlling your attention stream. And they can serve up information to you, collate data, and they can control what's coming to you. And that's very valuable. So it doesn't have to be an operating system that does this. It can even be a platform. Once you've enabled the platform to know information about your interests and your attention, there has this creep factor. Privacy is a misalignment of a user interface, where we feel that we're giving so much of our information over to these systems, and there's not enough of a transparency as to what's happening with that information. And so when you talk about giving your identity over to your devices and to cloud services, it has this creep factor. What are they going to do with my information? What if your information, which is a new form of digital wealth actually, that these companies are sitting on, what if this information was truly your possession? When you go to a doctor, you don't go to one doctor and each doctor be his own silo. For example, when you log into Google or you log into Facebook or you log into Twitter, each one of those is their own silos. And you can't take the information from one silo into another. When you go to a doctor, imagine if your entire medical history had no consequence and they just took you at face value. No, you want to be able to take all that medical history and bring it to bear in this situation. Banks work in a similar way. Just because a bank has your wealth, it doesn't mean that they own it. They can use it, but it's still yours. So what if our user information was something that really belonged to us, and there were protocols and systems to ensure that? But we can offer it to Facebook, offer it to Twitter, offer it to the next application that's coming along, and we can choose what information we choose to share with who, and that information belongs to us, and we can also audit how this information is used in order to target us and transmit information to us. What if information was truly our property? That would take the creep factor a little bit away from the idea of sharing more of our information in order to embed our identity. But all of these things in themselves will not scale. So there's essentially two paradigms in software development. One is embodied by Steve Jobs, and one is embodied by Alan Keyes. The Steve Jobs paradigm is the products paradigm. It's the App Store paradigm. It's where you create polished experience and polished products, and you offer them at a premium. And it's great. You get great software, and you get great technologies that way. But it separates the distance between the developer and the consumer by a big deal. But in doing so, you create a market. And in doing so, you also create one of the most lucrative companies in the world. Users, however, are not able to reason very well about how those products are made. You're not able to just crack something open and hack it. But there is the Alan Keyes paradigm. And that paradigm is the hacker paradigm. It's less product, it's more Lego. And Alex Keyes has this grand vision that essentially programming would just be literacy. That the same way that you learn mathematics, even though you're not a banker or a mathematician, but you know how to do it when you need it, in the same way programming is something that everyone will be able to do. Why is this important in building interfaces and systems and platforms that think? Well, there is a limit to how much people in Palo Alto can reason about my life in Vienna. There is a limit. And to reason about all the ways and the different modes in which I want to use their software. And if I have to wait for every new release, every time I want to better adapt with the information that's flowing into my life, that's not very scalable. But what if writing computer programs was much simpler? What if, instead of just being able to do configurations and filters, we can actually write filters which have logic in them? Alan Keyes had this grand vision. And it was one of the reasons why he helped develop object-oriented programming. The idea of object-oriented programming was to take the concepts and the metaphors that people were familiar with and that had existed and translate those into programming. Now, I personally don't like object-oriented programming. One of the worst things that you can deal with in programming is state. And the last thing you want is your state to be scattered. And that's what object orientation does. But the idea behind it is phenomenal. Make everyone essentially a programmer. And so Alan Keyes, he's requested money from the US government to start this kind of like initiative, which is about reinventing programming and making programming something that is accessible to everyone. And so you've taken away silos. You've taken away the creep factor of privacy. And you've taken away the barrier of entrance for those who don't know programming so that they can adapt systems and write systems that can help them pay attention rather than having it dictated to them. And so you can imagine that you have an operating system where apps are not necessarily pushing notifications, but floating notifications in a given format. To say, for example, this is a photo, and it was taken at this time, and it was sent to this person. And you have a format for transactions, a format for events, a format for meeting acquaintances. And these formats are open. And these formats are served into the operating system or the platform. And you can write filters, and you can write subroutines on these platforms, which are simple, but allow you to group information and to decide, for example, listen, I'm sitting at a cafe. If I'm sitting at a cafe and the message is coming from work, then ignore it, unless maybe I'm there at a particular hour with a particular person. What if you could simply write that on a platform on an operating system, and that could control the amount of the speed and the timing of the messages that came to you? It's an idea. One of the hardest things to grasp about Moore's law is its implications. In an article that was written at the time of the celebration of the 50 years of Moore's law, the point that they hit in the article is that they said that when you build, let's say you're developing a feature or a product, and you're targeting to release it in about a year. If you're building it with the assumptions and the technologies of today, sooner or later, that pattern, Moore's law, is going to prove that when you launch, you're going to be already out of date. One of the hardest implications to grasp about Moore's law is that the things that are seemingly impossible today, by the time we're launching, will be possible. So what today are some of the assumptions? Constant connectivity. The fact that every single app requires you to sign in with your identity, pretty much on your phone. Identity is a layer in software. Your information is always going to be on the cloud. Connectivity is just going to be rampant. And your phones and your devices are essentially just thin clients. These are assumptions we can make. And Moore's law is going to bring those to us faster than we can deliver on our product on our product roadmap. And so when I was thinking about these things and thinking about where do the things that I build fit into these new emerging platforms whose basis is going to be on attention and whose basis is on notifications and messaging, how do we bring things of value? It really does help us to really stretch our imagination and really think beyond the horizon as we're doing in this conference, and imagine the world. That's not that the world the way it is today, but the world that it will be tomorrow or in 5 years. And it's really inspiring. And there's a lot of challenges there, but it's also a great way for us to build things which are of great value. So I'm going to end with a quote. Those who understand Moore's law know that its corollary is that the impossible is the inevitable. Thank you, Mark. Thank you, Beyond Tellerrand. Thank you all for your attention.